Bonjour, good morning to everyone. Fabrice and myself are pleased to briefly introduce to you the project of construction of a demonstration plant to produce a high-density renewable fuel to meet the demand of the fossil-free fuel for aviation industry. The project is called Neutral Kero. Let us introduce ourselves. I'm Guy Davister, acting as today as board member of the company Desmet Engineers and Contractors. My whole career has been dedicated to the construction of industrial complex worldwide, acting as general manager of SNC-Lavalin Europe, the Belgian entity of the SNC-Lavalin Group, and then as CEO of Desmet Engineers and Contracting until my retirement in 2018.
Good morning, everyone. My name is Fabrice Orban. I joined Hamon in March 2020. Before that, I have spent 14 years at John Cockerill in various operational positions, primarily in the industry sector and in the metals division. I also spent 7 years doing consulting work at McKinsey & Company, and I graduated from École Polytechnique in Paris and the University of Liège. So the project Neutral Kero is being developed at the initiative of various promoters, 4 promoters. The first one is RESA. RESA is the main operator of the distribution network of electricity and gas in the Liège province. RESA has acquired a significant expertise in managing the energy networks and retains all competencies needed to operate networks in a fully integrated manner. RESA is currently acting as coordinator of the consortium.
Then University of Liège is acting through 2 departments. The first is the Montefiore Research Unit Department of the Professor Damien Ernst. This department has acquired a strong competencies in developing sophisticated models for the optimization of the energy system. Second department is the Chemical Engineering Department of Grégoire Léonard, lecturer. His team holds a solid competencies in modeling, developing and designing chemical process, and especially on the technology of Fischer-Tropsch.
Hamon, yes. So maybe now a few words on Hamon and Desmet. Hamon was founded in 1904 and developed over the 20th century as a global leading provider of cooling technologies, first for the power generation industry and then later on for other industrial sectors. At the end of the 80s, the group entered the area of air quality systems and is now a significant player in various flue gas treatment applications across various industrial sectors. As part of this development, capturing CO2 is a strategic orientation of Hamon.
Desmet Engineers and Contractors has been founded in 1990 to act as an engineering and general contracting firm. Over the 30 years of activities, Desmet has successfully executed more than 400 industrial projects worldwide in the agro-industry sector, edible oil, sugar, protein, and fertilizer, and is particularly active in the biofuel industry of the first and second generation. Desmet carries out projects from their conceptual design, feasibility study, up to their complete delivery. It has construction, commissioning, and performance demonstration. Thanks to such a team, we are mastering all aspects of the project of production of fossil-free kerosene that will be briefly introduced to your attention. The project of production of a fossil-free kerosene meets the environmental objective of the Walloon government in an appropriate way. Just a quick reminder of those key objectives and their goal for 2030. Decarbonation of the sector such as the mobility, the construction, the energy, and the agriculture, with an objective to decrease the greenhouse gas by 37%. The use of renewable energy in sectors such as renewable energy in transportation, green heating system, with the objective of an increase of renewable energy by 23.5%. Energetic efficiency, where the target is to increase by 23% the efficiency. All those developments are supported by a fund of 110 million euro per year to meet the challenges.
Now, what are the actual challenges of producing a fossil-free fuel for the aviation industry? We believe that the optimal approach must meet the two following challenges. The first one, the fuel must contain a maximum energy amount per unit volume. The second one, the fuel should avoid to redesign completely the airplane propulsion system as well as all the airport or ground-based infrastructure. On the following table chart, you can see that electric batteries on the lower left corner actually do not meet the energy criteria, neither in weight nor in volume density requirements. On the other hand, if you look at the extreme right part of the chart, hydrogen is definitely a high energy fuel per unit mass, but its storage condition in terms of pressure and temperature will require a complete redesign of airplane engines, as well as tanks, as well as all the related airport infrastructure. This is the reason why we believe and we are motivated to investigate the option of a fossil-free kerosene.
The Neutral Kero project intends to demonstrate the technological and the economical feasibility of the production of a fossil-free kerosene, thanks to a robust modeling of the most appropriate mode of production, and this is the main task of the two university departments, and a complete integration of the unit operation and design of new equipment items, and this is a program of the industrial partners. The concept is based on the use of a carbon-free electricity, and consequently the modeling will integrate transient operating modes. The key technological blocks are the electrolysis of hydrogen, the capture of CO2, this can be preferably from atmosphere or also from fatal CO2, and the catalytic reaction through the Fischer-Tropsch process completed by some separation step. The project intends to study and optimize the Fischer-Tropsch reactor starting from CO2 and not from carbon monoxide as usually used. To achieve the goal of demonstrating the economical viability of such production scheme, obviously, kerosene will be the main production, but all other flow will be economically valued. It has the synthetic gasoline and the excess of thermal energy that will be integrated into urban network.
So let us describe the project itself. The Neutral Kero project will first start by a feasibility and research study that will be synthesized into the production of the front-end engineering design of the demonstration plant. In order to reach the objective, that first step has been divided into 6 work packages, as you can see here on the page. The first work package, developed by the Montefiore Research Unit of University of Liège, will produce new methods to integrate into the techno-economical concept the variability of the renewable power sources. It will also deliver outlines of the most promising configurations for a given set of operating conditions. The work package number 2 will contain experimental demonstration of the Fischer-Tropsch reactor working on CO2 at pilot plant scale, as well as numerical analysis of such operation. It will include development of a new catalyst or various new catalysts. This will be the task led by the Chemical Engineering Department of University of Liège. Work package 3 and 4. Those 2 work packages will include a thorough review of the literature on the various systems of CO2 capture in view of identifying the most promising ones. This step will then be completed by the construction of a pilot plant dedicated to capture atmospheric CO2 and will deliver the complete conceptual design of that operation for the demonstration plant. Hamon will lead that development with the support of the Chemical Engineering Department of University of Liège. The work package number 5 is led by Reza. This work package is dedicated to the selection of and the application of the developed methodologies to a selected industrial site. The deliverables of this work package will be the optimal configuration of the fossil-free production of kerosene for the demonstration plant. This work package will contain the conceptual design of the multiple connections to the various networks. Finally, work package number 6 will contain the front-end engineering and design of the demonstration plan, together with the estimation of the investment cost as well as operating cost. This feed package will integrate the constraints of the selected industrial site together with the ones coming out from the safety and security analysis of the plant operation. This will be the task of De Smet Engineering and Contractors and Hamon together.
The second step of this project is the construction of the demonstration plant on the industrial site that is scheduled for 2025. The stakes we target to meet with this project neutral KERO is to support Wallonia to recover a part of the energetic independency and to develop a first-class technological expertise that can be commercialized and exported, to promote the local and academic research and development, and to support the reindustrialization of decommissioned sites with projects requiring a complete range of long-term employment. We thank you for your attention. We are committed to build the future of the region.
And we look forward to interacting with you.
Pas mal, hein?